have any questions about anything? Yeah. So for the current assignment with the matrix, you're welcome to add any new functions or add any new members, but you cannot change the signatures of any of the functions that I've created for you. Yeah. The operator plus and whatnot?
Minus. Don't reference that argument.
Oh, so operator negate? You can still do it outside the class if you want to. So I assume you're talking about something like this method over here. Let's see. Let me figure out. Oh, come on. Don't freeze on me. This one right here, 70. This is operator negate, not operator minus. So this is like negative vector, right? The subtraction guys are down a little bit lower. These ones are the subtractions. So that's a minus b versus negative a. I want you to add the scalar to every element in the vector. Yes. Any other questions? Yeah. I mean, I guess technically you could, but probably is not needed. Anything else? Okay then. I wrote some slides for you guys on pointers if you want to review the information that's there. Some things that I think I didn't remember to discuss. One thing is that after you delete the contents pointed to by a pointer, that pointer still points to that location in memory, right? So if the pointer is pointing at location 100 in memory and you say delete pointer, it will go to location 100 in memory and delete what's there. But the pointer is still pointing at location 100, even though it's now deleted. If you attempted to dereference this pointer, the resulting behavior is undefined because you're accessing deleted memory. In order to help prevent yourself from doing that, you should make sure to set your pointers to null pointer. Excuse me, after deletion, so that you remember that you're actually not pointing to anything. Does that make sense? The other thing is the question might be like, when should I end up deleting my dynamically allocated variables? The correct answer is sometime after you're done using them and before the program completes. It's going to be problem specific. A lot of times you'll end up deleting the pointers or that memory right after you're done using it. But some objects might not delete it immediately because they're planning on reusing that space in the future, so to save some time. If you do have dynamically allocated members inside your class, or again you have pointers that point to some dynamically allocated memory, make sure that you end up deleting those things in the destructor. We're going to see that today. You can, if you want to, dynamically allocate 2D arrays. Right. So here I make an integer pointer, and I make a new array of integer pointers. Then each of those integer pointers now points to 5 new integers. So this would make me a 10 by 5 array of integers, and I would still be able to access it by doing like 2D array at I at j to access that element. I have an array of arrays, just like in Python you can have lists of lists. Again, you can keep going as high as you want, so you can have arrays of arrays of arrays of arrays of arrays out to any single dimensionality that you wanted. So this is an example of a function that creates a 3-dimensional array. So we create our pointer to our 3D array, right? And that he's assigned to be equal to D1 new integer double pointers. Then we go through that loop. Then each one of these integer double pointers points to D2 integer pointers, and then each of those integer pointers points to a array of D3 integers. So an array of arrays of arrays, and then we end up returning. Over here on the right hand side, I end up deleting the object. So notice, like we kind of talked about at the end, I have an integer pointer reference. So I have a reference to an integer pointer that I'm trying to delete. And notice that the deletions happen in the reverse order of creation, right? First, I created the 3D array. It actually ends up being the last thing that I delete. Over here, right, we created our integer pointers. Each of those gets deleted right here after we end up deleting the array of integers. Sorry. These allergies. And then the reason that we accepted a reference to the triple pointer was because we wanted to set it to null pointer after we were done. Are there any questions here on this slide? Doing the deletions in the other order would be undefined because you would lose your, you would delete the space to the pointers and then you would try to dereference it to access it. Yeah. So notice that like this new right here, sorry, corresponds to this delete over here. This new right here is deleted right here. This new right here is deleted here. So notice that first I created the double pointers, then I created the single pointers, then I created the integers. Here I delete the integers, then delete the single pointers, then delete the double pointers. Does that make sense? So that's why maybe the deletions are happening. Oh my gosh. That's what I mean by the deletions are happening in the reverse order that the space was allocated in. So this is what's happening. This first new over here creates integer double pointers. So here's 3D, and he's pointing over to this array of integer double pointers. Each of these double pointers points to a new array of integer pointers. Each of these integer pointers points to some ints. Right, these guys are all integers over here, and this would be the same thing drawn out for each row. So the way that the deletion happens is first we go here and we delete all of these guys. Then we delete all of, then we delete all of these, and then we delete this. If we had tried to delete it in the same order that it was declared, well, first we would delete this, and now I can't access anything over here on the right anymore. That's why the deletions have to happen in this order. Does that make sense? Yeah. There was a question. Little feedback. Okay. Any other questions? Okay. I think we talked about all of these mistakes. One thing again is to make sure that you use the correct form of delete whenever you do the allocation. So if you allocate using the square bracket, you want to delete using the square bracket. And the number of times that you call new should be equal to the number of times that you call delete if you want to make sure that you free up all the memory that you've allocated. If the number of deletes, calls to delete, are fewer than the number of calls to new, that's when you end up with a memory leak. So we're going to do an example now, and we're going to create the vector class. So first thing I want to do is I want to create a repository, a Git repository. How do I do that? ECS enable integration, use Git. And then the first thing that we're going to want to add is a git ignore. And we're going to ignore cmake -build -debug and .idea. And then we're going to also ignore this desktop.ini. And then we need to go add these two guys to our repository. I did with Control-Alt-A. So now we're going to make a new class. Oops, a level higher. This one's going to be a header file only for our vector. This is like a vector, like the standard vector implements. And you guys have already seen templating before, right? Over functions. We're now going to template this class. So we can template classes as well as we can template functions, and it's no different. You just say template, type name, and then whatever you want your type to be. So we're going to have a vector of t's to allow us to generalize to be a vector of integers or a vector of doubles or a vector of strings. We can also template just like the vector class does over the type that we contain. So what am I going to need inside my vector class to get this implemented? So what? We're going to need an array, right? We're actually going to need our members. So what's our declaration of this type going to be for our contents? A t-pointer, correct. Right? We have a pointer to our contents, and we're going to need to allocate an array for these elements. Anything else that we might want to keep track of? Again? We will create iterators in a little bit, but what other members might we want to know of besides our elements that are inside of us? Our size, right? So we might have like an int num elements. So these would be the number of elements that are inside of us. And we might also have like an int cur size. So our size and the number of elements might not be the same. So you might have space for 10 things. So cur size would be 10. But the number of elements we might have might only be 3. We might only put 3 things in there. Does the distinction between those two make sense? Okay. So we're first going to start with our constructor. So we'll make a vector. And maybe the first thing might be like an int num elements. Right, so this is going to make a vector. Each of the elements will be initialized to this value. Does that make sense? Or each of them will create this many elements in our vector, and they will all be default constructed. Right, using the default constructor for our t's. Does that make sense? So then the other thing that we might want to do is make a vector of, again, like int the number of elements. And then we might also want a const t reference val. So we might want to create these elements, each initialized to this value. Does that also make sense? So what should we go about doing in this function right here? Notice that I'll need the header file, and this declaration outside the class has to denote the templating again, and it's a vector of t, again, for the outside declaration of the object. So how could we create a vector of num elements big, each default constructed? So first we have to make the space. So what would we do to make the space? No, not quite, right? Because we want to be able to create a bunch of elements. What's the keyword we use when we want to make stuff? New, right? So we would say something like contents is going to be equal to new. And then we want to make new what? T's. How many do we want to make? Num elements big, right? Then our num elements should be initialized to be num elements, right? And since we're kind of running out of space here, we'll move it down. And then our size should be initialized to be num elements. Yeah.
Why don't you have a file?
Because this is templated code, right? Remember, all your templated code goes in the header? Okay, well, in case you forgot, all your templated code goes in the header files, right? Templated code does not appear in CDPs. That's why it's all going to be in our .h. And then what would we do over here if we want them all to be initialized to val? Well, first, right, we still got to make the space like we did before. Right? And now that we've made the space for all the elements, what should we do? So populate them. How do I do that? Iterate. So like for int I equals 0, I less than the number of elements, right? Contents at I is equal to val. Right? Does that make sense? So we'll start off with some other easy functions. So let's say we wanted to have a const t reference at int position const and a t reference at int pos. This is the one that allows only for reading from the object at that position. This one allows you to both read from that object and also write to it. So what are we going to do here for this function? Great, contents at pos. Right, we're assuming that these things are going to end up being in bounds. If they're not, undefined behavior. And then also return contents at pos. Now let's assume that we wanted to define some operators. So we might have something like a const t reference operator square bracket at int pos const, and then again, but without the const. Right? This would allow you to now do the indexing on it. What do you do here? Oops, this one didn't pick up the const. So what would you do here? Turn at pos. Right? We just call our at function to do the work for us. This makes it so that because these two functions have the exact same functionality, the operator bracket and the operator at, or not operator at, but dot at, we should probably just call dot at so that if we screwed up in at, right, then we can fix at and also fix the square brackets instead of having to make sure to do the changes in both spots. And then again, we can just return at pos. This version, this call to at, which of these two ats does it call? Does it call this at function or does it call this at function? Does it call the first one or the second one? How can you tell? They both have const at the end, right? So remember, your const functions can only call other functions that end with const on yourself, right? So this function right here cannot possibly call this at because this at is not marked const at the end, and it could potentially modify it ourselves. And this one has to call this one. We do need to also write a destructor. So we might have tilde vector. It also needs to be virtual, don't forget. So again, remember in our destructors, I know we haven't really written too many of them because we haven't had need to. Our destructors should release any space that we've dynamically allocated. So what should this code look like? Delete square brackets, contents, right? And if we want to be really safe, we should say something like if contents, then delete. This check right here, the if contents, is the same thing as doing if contents does not equal null pointer. The exact same thing. So if there's stuff there, then we delete it. Does that make sense? Now we'll get to some more complicated ones. Let's say what we wanted to be able to do is we wanted to be able to insert a value at some position. So void insert a const t reference value at some int position. Right, so this should go and add the element in, right, while still keeping the old stuff there. So if we had something like this, A, B, C, C, D, right, this would be elements 0, 1, 2, 3. If someone said insert the value Z at position 2, then what we would end up with would be A, B, Z, C, D. Does that make sense? Okay. So how do we make that happen? So yeah, the first thing that we should do is to check to see if we have enough size to fit that thing in there, right? If we do already have enough space to fit the element, we can just add it in after we move the other elements over. But if we're not big enough, we're going to have to resize to some new size, right? So you might say, you know, if you might now provide an operator for our size, an int size const. Just return pure size. We should probably say, normally like the size actually returns the number of elements. And then capacity is what tells you what your current capacity is. So int capacity const. Return pure size. So we might say, you know, if size plus 1 is greater than or equal to capacity, right? So if the number of elements that we have plus 1 would be greater than or equal to the capacity, we need to resize ourselves to be, what do you want our new size to be? We could do new size plus 1. We could choose to double our size. We could do a lot of different things, but let's just make our size be 1 more than it is. Size plus 1. So we will resize to that many elements. And then, so after we've resized to make enough space, again, I'm just assuming this function exists, and I can go back later and write it. So what's going to happen? What are we going to have to do to make this happen? So after we resize, right, currently we had A, B, C, and D. After we resize, we'll end up having A, B, C, D, and then a blank spot. So what should I do next after I resize? Yeah, so we need to move these elements to the right. Like move the D over here, then I can move the C over here, right? And then I can replace the C with the Z. So how do I make that happen? Okay, how are we going to use the at function? Yeah. Yeah, we kind of need to start from the back, right? So we're going to assume that resize has increased our capacity, but hasn't changed the number of elements at all, right? So we would probably say something like for int I is equal to size, right? Again, this is the number of elements that we have, right? I what? And then you guys said you wanted to go backwards, so it's going to be a minus minus. So I'm starting right here, I guess, technically. Because our size hasn't changed, the number of elements hasn't changed. So I'm starting here, and what should I do with this element? We'll move it to, take this D and move it to the one element to the right of it, right? So how can I say take the element that I'm currently at and move it one element to the right, copy it over to the right? So I changed my capacity, right? My total, remember size is confusingly the number of elements. Size gives back the number of elements. Capacity gives back your current size, how much space you have. It'll increase current size, but leave num elements alone. So how can I make the the element to the right equal to me? Yeah. So like we could do something like at I plus 1 is equal to I, or at I, right? So the element to my right is equal to me. That's going to make the D, or this guy equal to the D. Then the C, we're starting right here, right? So make this element to my right equal to D. Then we move over, we make this element equal to the C. But how long do I want to keep going for? No, it's going to be plus 1. Because when we're starting this loop, we start here at the 3. 0, 1, 2, 3. Oh. So you're right. It should be minus 1. Correct. Nice catch. Because our capacity, our number of elements is 4, right? 1, 2, 3, 4. So the element at position minus 1, the 3 is equal, or other way around. So we're at position 4, right? Position 4 is equal to position 3. Copy the D over, right? Then I need to move over here. Position 3 is equal to position 2. Copy the C over. Now, once I copy the C over, do I want to keep going? Given our example that we're trying to insert here at position 2. So I want to keep going for how long? I is greater than the pause. Correct. Now that I've moved the elements over, right, I need to go add the new thing in. How do I make that happen? At pause is equal to wow. And then, right, we've added one more element, so plus plus num elements. We have one more thing. Do you guys have any questions here? Yeah. You could do I does not equal the position. That would also work. So now we have to come up with our new problem, which is to resize. So we might have a void resize int new capacity. So what should I do here to make my size be equal to my new size? Or if we just said like cur size equals the new capacity, right? Is that actually going to extend it so that we have more elements here? Is that actually going to allocate more space? If I just said the new size is now 5, is it going to make any more space? No. So what do I need to do to make the more space? So the way that new works is that you can't like reallocate the size of that pointer or reallocate the size of the space that we've allocated before. You have to do it as a single chunk. Does reserve exist? So we could use, if we want to write a reserve, if we want to call reserve, we have to write a reserve function. Right? Remember, .reserve exists on vectors, but we're writing the vector class, right? So it's not there. Yeah. Or with the new capacity, because like this would also make it so that if we wanted to shrink down, right? Like if I only wanted to shrink down to make it so that my new capacity was 2, I'd be left with just A and B. So it works for both ways going around. So how am I going to make that happen? Is it okay if I just say something like this? my contents is equal to new T new capacity. Will that work? Why not? Well, we'll lose all the old stuff, right? And we won't have deleted any of the old stuff as well. We'll have lost that pointer. So we probably need to make a temp, right? So I have a T pointer temp is equal to this new capacity, right? So now I've made this new blank space that's big enough to fit however much I need to fit. So what should I do next? Copy over the elements. How many elements? Size elements. But what happens if we shrunk our capacity to be smaller? We want to do the new capacity. So we want to do the minimum, right, of new capacity and the current number of elements that we have. Right? Does that make sense? So we can include algorithm, because that's where min is at. So we might say like int num to copy is equal to std : min, and it's the min of new capacity and size. Right, so then we can do like for int I is equal to 0, I less than num to copy plus I. And then we can just say something like temp at I is equal to contents, or probably even better, at I. Right, so we copied the elements over. So what should I now do with my original stuff? Delete it. So delete square bracket contents, and then temp. One other thing that we should probably check to do is this. Say null pointer, and then do if new capacity is greater than 0, temp is equal to new T capacity. So if someone decided to make their new size 0, right, you want to do the deletion. Yes? Say it again?
Why do you
Instead of snake case, just happens because sometimes I write in Python and sometimes I write in C++, and they use the differences. And so sometimes I'll use camel case and sometimes I use snake case, and it just gets mixed. If we want to, it's fairly easy to go change it by just clicking on the variable and do Shift F6 and then write in its new one. You guys have any? Oh, we have one thing that left that we need to do. What's that thing that we need to do? Her size is equal to, yeah, new capacity. Does that make sense? Oh. Yeah, I guess if we shrunk in size, we would need to change the number of elements. So we could say something that the number of elements is equal to the std : min of the number of elements and the new capacity. Will still be kept at the number of elements because the number of elements won't have increased. If the capacity gets smaller, we're going to lose some elements. Any questions here? Okay. There could be some more fun stuff that we could do, like erasing, right? But we also, since we have insert, we have some things for free. Like we could do like push front for free now, because you would just insert at the end, right? And so that would be really, really easy to implement, which we'll do. we will do void pushback a const t reference value. And what we could do is we could just do something like insert. And we want to insert, of course, value, but at what position? The last one, which is size. Right? Because again, we had like something like 0, 1, 2, 3. Our size was 4, so we want to insert at 4 to add the new element. So we get pushed back for free. Now you guys said that you wanted to do some iterators. So we'll create a new C++ class. But again, since our vector is templated, our iterators also have to be templated as well. So create header only. And we will start doing the const vector iter first. So what things are we going to need? Again, template, type name t. What things are we going to need as our members to make this happen? Yep, a position and a vector, not quite a vector, but a reference to a vector, right? So, question that I should ask you guys since we talked about pointers, should I have a reference to a vector or should I have a pointer to a vector? So who thinks a pointer to a vector? Who thinks a reference to a vector? So for those of you that chose pointer, why should we prefer to use a pointer to a reference? But our precision is keeping track of which element that we're at, right? So like you could technically get away with having a pointer to an element inside of the array, and then you wouldn't need to have the vector at all. But we're not going to do it that way because it's a little bit more complicated. Well, not more complicated, it's just a little bit more confusing for you guys. So for my vector, which I'm going to need to forward declare, so pointer, those of you who said pointer, why do we want a pointer to the vector? Because again, if we want a pointer to a vector, that means we're able to point at different vectors that we're iterating over. Okay, probably reference is probably what we want because the thing should always exist, and we probably don't want to make it iterate over something different. If we did want to make it iterate over something different, then yes, we would need to use a pointer. So I guess my question should be to you guys, do you want to be able to do something like this? With your iterators? You want to be able to write that kind of code? Yes? Iterator 1 is assigned iterator 2? No. So some no's. If you said yes, you'd have to use a pointer, right? Because we need to be able to replace which vector that we're iterating over. If you use a reference here, you're not able to do the assignments. It's just not going to work. So if we do choose to do a reference, a vector reference, vector, then up here to make sure that bad things don't happen, you have to do this. A const vector iterator reference operator equals const vector iterator reference right hand side equals delete. Now I can't do assignments anymore. What this says is my operator equals function is deleted. It does not exist. The compiler will not make one for me. Right? So I won't be able to say vector 1 is equal, or iterator 1 is equal to iterator 2. That function no longer exists. It's gone. Right? And the reason that I'm not able to do that is because I have a reference for this member and I can't reassign my reference. if we want to be able to do operator equals, the assignment operator, you'd have to make this be a pointer instead. But anyway, carrying on. What should our constructor look like? What parameters should we take in? I guess this should actually technically be, since we're doing the const iterator, should be a const vector reference. We can't modify anything inside of it. What information do you need to be able to build a iterator? A vector, right? So we'd have a const vector iter. A const vector reference. And then we would maybe also need a position to start at, right? We could also define another version that just takes a vector to iterate over. And then doesn't take a position and would default to being the beginning. So over here, fairly easy. We just say vector is assigned vector and position is assigned position. For doing the forwarding construction, nope, not in place, thank you. If I want to do the constructor forwarding, I have to say that I want a const vector iterator of type t that takes in a vector and, come on, you can do it, 0. As I say, I want to say which vector's constructor do I want to call, the one that's also of type t. So, what other methods should we define on our iterator? Yeah. No, this right here is saying call this constructor. That's it. Also, something that you're going to see that's going to be a little unique. Inclusive vector is going to be down here after my class declaration. This is going to prevent the circular inclusion problem again. So I guess technically, to make things work, because life is interesting, this declaration has to come after my class's declaration, because the vector is going to need the iterator, and the iterator is going to need the vector, and if they both had the includes at the top, you wouldn't be able to get things working. But what other methods should we have defined on our iterator? Maybe like ++, right? And star to access the element. We will pick this up on Monday, but think about what we need to do to make this happen. Your next homework assignment after matrix is going to be very similar to vector in that you're going to be implementing a container class, but instead of a vector, you will be implementing a doubly linked list.
I was actually going to ask you, are we going to do a linked list?
Yes, you will be doing a linked list.
That's so cool.
Doubly linked list? Probably, yeah. But I also have some ideas of some fun new things, like for like iterator problems, we might have it so that you extend your matrix solution, so that you're now able to provide row iterators, you can iterate over the rows, and column iterators, so you can iterate over the columns.
Or another data structure.
Say it again?
Or another data structure.
Or another data structure? Oh, like a stack or something? Or a tree? Like, we could do trees instead of linked lists instead, but those are a little bit more complicated, especially if you want to provide iterators over the trees. Because you do need to like visit every element, so you might provide like, I want a like a depth first iterator. So it goes all the way down and then back up and then down and then back up. Or you can have like a depth first iterator. And then like a cool thing that you might also be able to do with like trees or even like a linked list is you could like accept a function. You can have a method called apply that accepts a function and it applies that function to each element in the container. But again, generally that's more done with something like with the iterator. You could iterate to the begin and to the end, and then you would apply the function over it using something like an algorithm library. But anyway, what's your question?
So like I'm trying to do matrix. Like I can't think in a more like trying to be like, but like I can't access.
So you could use, for example, the dot at or the square bracket operator. Those are public.
Oh, you mean they have direct access to?
No, like so you can call any of the public members like square brackets, or there should be an at or at, right? Square brackets are here. Square brackets are down here. At's right here, right? So you could call those methods because they're public, and those ones are able to access the elements inside the vector.
So, but I can't change the function, right? So I can make it a friend.
But you don't need to. It's public, right? You have access to every any class that declares a method as being public. You have access to that anywhere, right? So you can, since you have a vector, right? You can just do the element at that position. This guy right here, you can't do like the vec.content. If you define some more like this isn't going to work because you haven't defined begin and end. So if you do create some like an iterator like object, and you have like a begin and end function, you can now call it here. Make what you want to have happen. And that function could be fairly simple. All it would have to do is return the contents begin, the contents end, implement those functions.
But
implement begin and end.
oh,
So if you don't want to implement those methods, you'd have to do something like for I equals 0, I less than the vector dot size plus I, right? Out vec dot at I.
yeah, that's much better.
But if you do implement begin and end, you could write this function here.
So, like, I'm confused. We're kind of writing a standard library, right? So technically, we don't have iterator in this case. So that's why we can't use iterator directly.
So you can't do, before you had vec.contents, you couldn't do the .contents because that's a private member, right? But what you could do is you could create some new members on your class, begin and end, that return vec.begin and begin, and an end return vec.end, right? And so now since you've implemented begin and end, and all you do is just return iterators over your internal member, you would then be able to have this code as you have it written right now.
So like, for the method like this, I don't know what to read.
Or
For matrix, matrix. So I was trying to return matrix 0, 0, 0. It works, but I don't know why.
so like the point of that function is like, let's say you have a vector that's like 1, 2, 3. So you want to transform this into a matrix that it's made up of the single row 1, 2, 3, right? And if you called like as column or as column matrix, you would get back a matrix, right, that had 1, 2, 3.
Yeah, the transpose.
So if you implemented as row matrix, yes, the as call matrix could just say call as row matrix dot transpose. But again, notice the types are changing. The type went from vector to matrix, right? So this is like, right? We're going from a vector to now a matrix, right? It's a contains one row, and then this guy, would technically be something like this in terms of like this implementation. each of these being a row vector. Right, because now we have 3 vectors that each contain one element, and each vector represents one row.
So the size for this is 3 individual vectors.
Yeah, this one has 3 individual vectors.
That one is just one.
That is that matrix contains one vector.
Understand. So what I need to return is a matrix object. Okay. So I have to create an instance inside of that matrix in order to call on that object.
Or for example, like one of your methods that's already there accepts a vector of a STD vector of matrix vectors. Right? So if you put that object yourself into a STD vector, then you could just call the matrix constructor on that and return it back.
We are talking about matrix class, right? Or
Yes.
vector class.
So because the vector class is the one that has the as row matrix, right? So what it could do is there is a matrix constructor that accepts a STD vector of matrix vectors. So what you could do is you could put yourself into an STD vector, right? And then you could pass that to that matrix constructor, which would then make a new matrix that contains those elements, and then you could return that.
I was running into one problem in my Connect app, in which I use your command for making 2 players. So it initializes the player class twice, so it makes 2 players, or 2 instances of it makes 2 objects of player. But how do you keep a tracker on one of them? Because one has to be player 1 and one has to be player 2, right?
So probably what you're going to need to do for that is, if you still want to call the players constructor, is first make an empty vector of players, and then you could have a new constructor to your player that accepts more arguments, like the I, right? Like 1, 2, 3, whatever, right? What number of player you are.
Yeah.
And then you could also have any additional arguments you need, maybe like the other players that are in the game. And then you could have a little loop in your game constructor that says, for I equals 1, I less than or equal to 2, make a new player with these new arguments being passed in, because that's the information you need, and then push them back into the vector of players.
Okay, so in the one you use for your tic-tac-toe, that you enter an input of number.
Yeah, because that's using the vector constructor that just takes in a number of elements to create.
Yeah.
But when you call that constructor, they're all default constructed.
Okay.
Right? So they're all called using the 0 argument constructor. So you couldn't do it that way because your constructor that you need to have called requires more arguments.
Right.
That's why you'd have to go have that little loop inside the body that goes and creates the player with the correct arguments and then pushes them to the back of the vector.
Thank you.
So it's better to start with the vector thing, right? Because the matrix will be constructed with.
I think most people will find it easier, yes, to start with vectors.
So say that for this one, it's a constructor that's copy all the contents.
Yeah, again, normally like this type of thing is something that you would want to do in the initializer list, not in the body. So you would see like colon, right, contents. You would just have, that's going to be too much. It'd just be like contents, parenthesis.
Oh.
Contents. Because you're calling the constructor. Right? So this just creates and initializes.
And then I don't have to do anything here.
Correct.
But okay, and now that it has a number of elements and the value, do I just change the contents?
So no, that doesn't make sense. It doesn't work because this just returns you a number.
Yep.
So you're like, this thing might get back 5. So you're like 5 is assigned 10. Does that make any sense?
Okay, so is it like contents
to
be...
So again, you're going to want to use a different constructor because your contents are a vector, right?
Yep.
And if you go and you look online on the constructors for vector,
Yep.
there is one constructor that takes in a number of elements and a value.
Yes, there is. So do I just okay? I think it was parentheses, right?
Yes, but it has to be done in the
Also in
initializer.
the initializer.
Yes, because you're creating the object here. After you reach the curly brackets, the object is already created.
Oh.
So now you would say contents up here, and then parentheses. So how many do you want? Some elements, and what value should they have? Yeah.
Okay. That's
Right? Because once, like here, the element is being built.
But
Once, right? It's being made, the space is being allocated for it, it's being initialized. Once you get to the inside of the curly brackets, that vector has already been created.
Oh.
It already exists.
So this is during the creation of the process of creation. This is like after it's created.
Yes, like your object has been created at that point.
Alright, I need to turn this up. Can you include the both header in this one and also the both header